I think last time I looked, there was 170 registrations. So thank you so much for everyone who's come along today. It's really heartwarming to be given the opportunity to talk to you about this study. And I should point out, this study isn't just me. There's a whole bunch of people behind the scenes in both Ocean Protect, Western Sydney University, ALS that have contributed to the results I'm going to present today. But basically, it's a big study. It's a very, very long study. And one thing I like saying is, unless you've got data, you're just someone with an opinion. And when it comes to the performance of Filterra bioretention systems, we have an enormous amount of data. This is probably, I think it is the biggest, or at least longest stormwater treatment asset monitoring study in Australia. And we're not stopping anytime soon as well. So certainly keen to present the findings. Look, but for people who aren't potentially familiar with Filterra bioretention systems, what are they? They're, long story short, they're just like conventional bioretention systems, but they're smaller. And we'd argue better, and I'll come to that a little bit later, but some key differences. So instead of using sandy loam filter media, like you see in a conventional bioretention media, we use what we call Filterra, which is the filter media. That is made by Ocean Protect. It's a very carefully made filter media blend that basically can treat water at a much higher flow rate than conventional bioretention systems. So typical sandy loam bioretention systems drain at, say, 200 millimeters an hour or thereabouts. Filterra is much higher. A design hydraulic drainage rate of 3.5 meters an hour, but we know in the field we get much higher than that, generally at least above 5 meters an hour. So yeah, another key difference is the mulch. So we put a layer of mulch on the surface of Filterra bioretention systems, and this is something I'd recommend for all bio systems. But it's long story short, it's a 75 millimeter depth of double shredded hardwood mulch. There's nothing fancy about the mulch. You could probably get it from Bunnings, but it's basically a hardwood mulch. A hardwood mulch that's gone through a wood chipper twice. And we put that on the surface of the filter media for two reasons. Number one, it provides a pre-treatment function, like a GPT or a screen, to screen out silts and fines that can otherwise block the filter media, which we invariably see for conventional biosystems. But another key reason for a mulch is just to help retain water within the filter media, which is great for plants and great for sort of all the biological activity within the filter media. So yeah, they're probably the key differences, but fundamentally, because the Filterra bioretention system can treat water at a high flow rate, they are smaller. Generally, Filterra bioretention systems are 3 to 5 times smaller than a conventional bioretention system, which is obviously attractive from reducing land take for treatment assets, but also helping to better integrate these systems into the often highly constrained urban environment. And there's two main types of Filterra systems, just like conventional tree pit systems, which we integrate into streetscapes, or the larger bioscape systems. And look, where would you apply them? Basically, just like where you're thinking about putting conventional bioretention systems, you could put in a Filterra biosystem. So the one on the left is at Silverdale, which is one of our larger bioscape or biobasin systems. And the one on the right is a Filterra system as well that's integrated into a streetscape in Tasmania. But look, here are some other photos, and a lot of people may not have seen these. But look, this is a system that was constructed. This is one of two systems at Warwick Farm. This was constructed in 2018 or 2017, I think, by memory. So it's about, 5 or 6 years old. And those trees, this is like a 200 square meter system. Those trees are about 8 to 10 meters high. And they were pretty small when they were put in. So over time, those trees have obviously grown. And that seems to be going very well with very little maintenance. Similarly, this is the second one out at Warwick Farm. Same deal, another bioscape system, wide diversity of plant species, etc. And I often talk about this one because it's right next to a creek, which overtopped during a flood event and deposited a whole bunch of sediment from the creek into onto the surface of the mulch, which would probably be the death knell of a conventional bioretention system. But long story short, we just had to scrape the sediment and the mulch away. And we did a hydraulic conductivity test, and it was still working perfectly fine in terms of maintaining that hydraulic conductivity. So just highlights the importance of that application of mulch on the surface of the filter media, which again is something I'd highly recommend doing for all bioretention systems. This is another example of a bioscape system out of Silverdale. This is looking at the same system just from a different angle. This would have been about, I think it's about 260 square meters. This would have been about 5 times bigger if it had been a conventional system. And those trees you can see in the background probably would have been knocked down to accommodate the biosystem if it had been a conventional system. So yeah, this is probably a couple of years old now. And yeah, plants are still establishing, but yeah, it looks right. Similar, this is another classic example. You wouldn't know this was a Filterra biosystem, but it is. This is a couple of systems. This is one system at Aura. This is, I think, 12 square meters. Would have been 5 times bigger if it had been a conventional system. Physically couldn't have fitted in. And that's only, this is the same site, just a different Filterra system. Both these systems have been in the ground for about a couple of years. So it's a couple of year growth of vegetation. So yeah, just growing and looking good and seemingly treating water to a high standard, which is great. This is an unusual one. This is, but I think we might see more of these. This is this isn't Filterra. This is a conventional bioretention system constructed in Kingston City, owned by Kingston City Council. It was constructed a few years ago, and Kingston City Council approached us to see if we had a better solution, and like they were looking to basically rectify it. By all, you know, qualitatively or visually, the system was in very, very poor condition, and some would argue that it has failed, and council were keen to basically get it completely rectified. So instead of just doing the same thing and expecting a different result, they approached us to replace it with a Filterra biosystem. So we took the 170 square meter conventional biosystem and replaced it with a 51 square meter Filterra system. So that's it, literally just constructed. Plants had literally just gone in the ground. Now that trough you can see is basically just a way of distributing flow across the surface of the Filterra system. We've never done this before. Kingston Council were keen to replicate what they'd seen at Edinburgh Gardens in Fitzroy in Melbourne. But generally it's a bubble up system that we have the larger bioscape systems. But yeah, so the remaining 120 square meters of the previous biosystem are just going to be used to landscape. So this will obviously, this 51 square meter system will obviously stay, you know, and treat water, but the remaining 120 square meters that was a fairly average looking biosystem will be just planted out, basically. This is a more recently constructed system, hadn't been planted. Just gives you an idea of some of the scale of some of these systems. This is a 290 square system, 290 meter square system in Western Sydney, in Ingleburn. And similarly, very recently constructed system. This was just after being planted. This is in one of 2 systems at New Norfolk. I think they're both about 60 square meters. So again, offline until the upstream construction activities are finished. But yeah, that shows you some of the key features of the system. You can see the bubble up points here, which help distribute flows across the system. We often get asked, is there anything special about the maintenance? Long story short, there's not. You don't need Ocean Protect involved in any way, shape or form. The maintenance activities are just like conventional bio. But we do recommend replacing the mulch every 6 to 18 months, just to help protect that filter media. Often the systems don't get that maintenance, but they seem to, keep charging along. But we certainly would recommend doing that to ensure the longevity of these systems. So yeah, you should never need to replace the filter media, and I'll come to that in a sec around long-term performance of these systems. But yeah, no specialist equipment needed. And like I said, you don't need Ocean Protect involved at all. It's just like conventional bio, removing weeds and pulling out litter, and every so often replacing the mulch. And you can probably get the mulch from Bunnings. This technology is quite widespread in the States, over 9,000 installed across America. And we've just recently constructed our 100th system in Australia. So they're becoming more and more popular, and certainly a lot of these systems being specified in addition to the ones that have already been built. So that's a very quick 101 on Filterra bioretention systems. What I really want to talk about now is the study itself. The study that we've been doing for 5 years now on one system in Western Sydney. So first up, before I talk about the results, I'm going to talk about the methodology. What did we actually do? So first up, when you're doing a monitoring study, you have to identify where you're going to do it. So we basically did a whole bunch of assessment, a whole bunch of baseline monitoring, started with 12 sites. And long story short, whittled it down to one site for various reasons, including easy access, etc. I'll come to that, where that site is in a sec. But before we do the monitoring as well, one thing we need to do is develop what we call a quality assurance project plan, or QAPP. That basically just provides a detailed understanding of what everyone's doing and who's responsible for what, and what are the rules in terms of that monitoring procedures, etc. So outlines rules around what's a qualifying storm. Often, obviously, there's lots of storms happen, but sometimes a storm might have, for example, really, really high concentrations that are considered an outlier or not typical. So sometimes we have to exclude events. Because obviously, if it was really, really dirty water coming in, the percentage reduction would be probably higher. So there's a whole bunch of rules around what is a qualifying storm or not, which I'll get to in a sec in terms of the protocols. But yeah, this QAPP basically specifies what the rules are in terms of qualifying and non-qualifying, how to do the monitoring, how to do the chain of custody documentation, et cetera, and reporting, et cetera. So basically outlines a whole bunch of rules and requirements moving forward before you even start the monitoring itself. In terms of that QAPP, you basically base it on appropriate protocols for stormwater treatment assets. So keep in mind, we started this study 5 years ago. So back in the day, there was obviously, I'm not sure if you guys are familiar with it, it's the Washington State Department of Ecology. Their TAPE, what they call the TAPE program for assessing stormwater treatment assets. That's been going on for a very long time, very rigorous, very extensively applied across Washington State and elsewhere. And that has a whole bunch of rules around a qualifying event or the reporting and monitoring requirements. So there's that protocol. Then in 2018, SQUIDP was obviously being developed. I think it wasn't finalized or released as version 1.3 until end of 2018, I think December 2018. And then at the time we had the Gold Coast City Council had their own protocol around how to monitor proprietary stormwater treatment assets. So what do? You basically hedge your bets and make sure whatever QAPP you're applying, it basically complies with all of the protocols. So SQUIDP, Washington State and Gold Coast City Council protocol. We often get asked, why don't you just use SQUIDP? For various reasons. I guess the key one was we started before SQUIDP was finalized. It was just in its infancy, but even now, today, 5 years later, SQUIDP, because of various known deficiencies within the protocol, it's not endorsed by a bunch of key stakeholders. So Stormwater Victoria, New South Wales and Queensland have all issued public statements outlining that they do not endorse SQUIDP, and they've outlined why, and they've asked for changes. Those changes haven't been made yet. And a bunch of other key stakeholders don't endorse SQUIDP currently as yet, such as Melbourne Water. There are a number of, I think there's probably 4 or 5 or 6 councils within Southeast Queensland that have adopted SQUIDP or will adopt SQUIDP. But outside of Southeast Queensland, we basically see very, very little even acknowledgement of SQUIDP even existing. So long story short, we developed a QAPP to basically comply with SQUIDP and anything else that might be introduced in future versions of SQUIDP or other protocols, depending on what was applied. So where was it? So the monitoring locations basically in a suburb called Kingswood near Penrith in Western Sydney. It's actually in the car park of Western Sydney University. And look, Western Sydney is probably a major growth area as well. It's just near Blacktown. But yeah, average rainfall, 720 millimeters a year. It rains, it's warm, subtropical climate, etc. The catchment itself, you can see here. The device you can see is basically located here, but it's basically a 420 square meter catchment. But it's a car park catchment, so 100% impervious, and it drains to a Filterra bioretention system, tree pit system, which is 1.2 by 1.2 meters tree pit system. So it's basically 0.34% of the upstream catchment. And most of these systems are sized, though. So Filterra is generally about 0.3% of the upstream catchment or upstream impervious catchment. So again, generally significantly smaller than a conventional bio. In terms of these are just some photos of the system being built in 2018. So digging holes, putting in concrete boxes, The Filterra system was in, obviously. That tree pit system there, that is the Filterra system. So water will come along the curb and guttering into there. If water gets too high, it goes into the bypass system. Now, that container there has a whole bunch of fancy monitoring equipment, which I'll explain in a bit later. But that was the system in 2018. And obviously over time, it probably hasn't changed much. So later that year, next year, 2019, more recently, hasn't really changed much. Hasn't really got any sort of fancy maintenance activities or anything like that. I think maybe it might have got a prune or two over the last 5 years, but and obviously the mulch has been replaced roughly every 12 to 18 months. But yeah, that's the system over time. I mentioned that that container with the monitoring equipment. Yeah, looks obviously closed doors, and obviously it's a lot of it's very a bit of a sort of a secret technology setup that we've got in there, because there's a lot of technical know-how that goes into it. But long story short, it measures flow coming out of the system at a couple of points. It measures rainfall, and it basically automatically samples water in and out of the system. So we can basically remotely program how frequent aliquots are taken from the inlet and the outlet based on expected rainfall conditions. So we can look at the rainfall predicted for that site. Whether it's a short event, you might have lots of aliquots being taken with small spacings. If it's a really, really long event over a day or two, you might space out your aliquot sampling a lot further out. And obviously the samples are then retained within an appropriate storage facility in that container as well for subsequent collection by more recently it's been ALS. So yeah, a whole bunch of technical know-how within that system. So yeah, it's pretty cool. And that expertise that we've developed at Western Sydney side and others, we've applied on a few other things as well, which I'll get others to talk about later on. Qualifying events. So long story short, over 5 years, we've got a lot of data, 55 qualifying events. So, and there's a real mix of rainfall events. So from everything between 1 to 64 hours sampling duration. So over 2.5 days. For each event, you've got between 6 to 105 aliquots. So sampling little things times 2. So sampling at the inlet and the outlet. So a lot of water being sampled, a lot of samples, big rainfall events, little rainfall events, whatever. And we've seen over for those 55 events, over 13 of the events have had over 5 meters of water draining through the system. So, I mentioned that hydraulic conductivity, a design hydraulic conductivity for the Filterra is about 3.5 meters an hour, but we know it drains quicker than that. And like I said, it's been observed to be well above, or at least above 5 meters an hour, 13 times. So a real diversity of rainfall events, as you might imagine, after 5 years. So what do the results show? Look, pretty good, basically. Now I'm going to try my best to try and show the data in a sort of, I guess, as clear a format as I can, but there is a lot of data. So I'll try my best. If you do want to delve into the detail, maybe I'm happy to try and do it here, or you can contact me separately. But long story short, this basically, these graphs here show concentration reductions for TSS, TP, and TN as just one example. So the blue dots are the sampling events and their associated concentration reductions, and the cyan lines you can see are the rainfall intensities observed each day across the 5 years. So look, long story short, a lot of data, but generally really, really good removal rates. If I look at all the events, so this is just if I look at all data for all 55 events. So TSS, dissolved phosphorus, total phosphorus, nitrates, ammonia, nitrogen, dissolved inorganic nitrogen, total Kel-Gel nitrogen, total nitrogen. You can see here 55 events. A couple of, I guess, things to, I guess everyone looks at TSS and TP and TN. but obviously there are other constituents there if people want to see. But in terms of concentration reductions, so a common metric we often use is efficiency ratio, or you can use concentration reduction efficiency, which is often expressed as a median. You can see the concentration reductions here. So this is all data, including the establishment period. So 86%, 80%, 40% for concentration efficiency ratio. If you look at the load removals, they are really high. So 96% for TSS, 94% for total phosphorus, and 71% for total nitrogen. Again, that's all data, all 55 events, including the 12-month establishment period for the system. And obviously a stormwater nerd like me likes to delve into the detail a little bit further. So if I backtrack a little bit, if I just look at the establishment period alone, we had 10 events, and you can see the concentration reductions and the load removals there. But long story short, the system has basically gotten better with age. And I think this is really interesting in terms of just general bioretention system performance as well. I think it's fair to say that we would expect, provided the systems are designed, constructed, and established and managed properly, we should see bioretention systems perform at least marginally better over time. They'll probably hit a plateau, and that performance will be maintained, but we're certainly not seeing any deterioration in performance across the lifespan of the system, because this is the first 12 months, and basically after that 12-month period, the numbers basically the removal rates go up. So this is after that establishment period. If I just scroll back, that's during the establishment period. So we go from, I know, like load removals of 78, 66, and 46 to 97, 95, and 73. So that's all 45 sampling or qualifying sampling events after that establishment period. If you want to delve into the detail a little bit more, there's a period which I think is probably the most rock solid data set. So it's basically a 12-month period, fairly recently, and all sample collection was done by ALS. So Ocean Protect, early on, we did collect the samples and send them to ALS. For this period, ALS did all the sample collection and obviously analysis as well. And it gives you an idea of probably a better idea of long-term performance as well. But long story short, you can see the results. Like, it's really, really high removals of TSS, TP, and TN. So again, load removal for total suspended solids of 96%, TP of 95%, TN of 72%. Recognizing that this is a bioretention system sized at 0.3% of the upstream catchment. So from my perspective, these results are extremely impressive. How does the data compare to other Filterra bioretention studies? I mentioned at the start, there's a lot of data for Filterra bioretention, and I'm not just talking about our study at Western Sydney. There's a bunch of other studies that have looked at real-world performance monitoring of Filterra systems that have been in the ground. Some of these monitoring events have been gone for a long time. I think the one at Virginia Beach is a monitoring program that's gone for like 8 or 9 years with 92 qualifying events. And there's obviously some other ones as well. But long story short, I've presented the efficiency ratio for the concentration reductions for TSS, TP, and TN. In the States, they don't generally do nitrogen because they're more focused on phosphorus and TSS. But you can see here the results are more or less fairly consistent. Really, really high rates of TSS, TP, and TN removal. How does that compare to before I go into a conventional bioretention system, another study that's very recently released is it's a longevity study done by Contech Engineered Solutions. They basically looked at 3 systems and that have been monitored for basically different time spans. And a lot of these systems, 2 of these systems had been in the ground for a very long time. Long story short, and the report is readily available from our website. But in summary, we saw consistently high treatment performance across the life of these assets with no deterioration and pollution removal, and also really importantly, no deterioration in the infiltration rate or the hydraulic conductivity of these systems. So with that in mind, and also recognizing the results that we've seen from our study and other Filterra biosystems, we're not expecting any deterioration in performance for these systems. So my thoughts are that Filterra bioretention systems, provided they are appropriately designed, managed, Filterra systems are appropriately designed, installed, and managed, they should last in perpetuity forever, recognizing that they're probably going to be enhanced biological activity over time. And I'd suggest that probably is a reasonable theory to have for conventional bioretention systems as well. I don't think there's, again, provided that bioretention systems are designed appropriately, installed, and managed in accordance with the guidelines and requirements, etc. Provided that all is done appropriately, these systems should last in perpetuity. But I looked at this is my attempt of trying to compile all of the field scale conventional bioretention studies that I have been able to source in the literature. And it's worth noting that the filter media specifications of these systems would vary from site to site, but you can see the results there. Long story short, the results are fairly variable. You sometimes see an increase in nutrient concentrations across conventional bioretention systems. So the effluent TN and TP concentrations, for example, often being higher than the influent concentrations. But yeah, look, it's fair to say, like I mentioned, like there's probably a bunch of reasons for the variation in the performance results for conventional biosystems. But I think a key one would be the variability in the filter media used for each study. And I think, to the best of my knowledge, there's no study to date of a real-world field-scale bioretention system using, modern day Forbes specifications. But obviously, Blacktown City Council have just initiated a 5-year bioretention system performance study using more recent filter media specifications. But yeah, that, to the best of my knowledge, that is a first. But long story short, the performance results for conventional bio are fairly variable, with often increases in nutrient concentrations across the system. But if you compare that to Filterra systems, the results for Filterra is very consistent. And again, a key reason for that is probably the fact that the filter media specifications are very consistent. The filter media that is made, that is applied for Filterra, is very, very carefully made. It's a 25-step QA/QC process. So the filter media specifications are bang on. I remember hosting a webinar with Benedict Sands, and I asked them, how do you ensure the quality of your filter media specifications? How do you make sure that your filter media produced is consistent with the required specifications, recognizing they're producing about 3,500 tonne a month or thereabouts? And the response was, it's really hard, but it sort of doesn't obviously answer the question, how do you ensure that the filter media is in an appropriate specification? And I think, look, I'm not sure about what other filter media manufacturers do, but certainly we do need higher standards with our QA and QC to make sure that the filter media, whatever the specification might be, we need to make sure that what is being produced is consistent with the target specifications, whatever they might be, whether they're water by design specifications or Blacktown or FORB or whatever. The information I've just presented today is all publicly available. The best source is probably just going to the OceanProtect website, and there's a review paper there. That includes all the published studies. There's 3 peer review reports, and obviously the council approved values across the joint. But if you're ever in doubt as to what councils allow Filterra bioretention systems and where, just feel free to just contact me. I'll let you know. It's because it's always changing. There's always councils specifying or approving these systems. And again, that's all publicly available. So what are the key study findings from this Western Sydney study? So fundamentally, the results are really good, like high TSS, TP, and TN concentration and load reductions. And those results are consistent with what we've seen in other studies of Filterra bioretention systems. And the results to date demonstrate that the performance has improved over time, which is great. Often I get asked now, what's the secret? That bioretention systems, Filterra is like 3 to 5 times smaller. Your results are consistently good. What are you guys doing? What's your secret? I think these are probably the 4 key reasons that I would sort of suggest would be the secret. So number one, the turnkey approach. So when a Filterra bioretention system goes in the ground, OceanProtect responsible basically, or at least involved in the design, the construction, and then we look after the system for the first 12 months. Now, I mentioned the filter media specification. We're absolutely responsible for that as well. So we make the filter media. So again, we do the design, the manufacture of the media, the installation, and look after the system for the first 12 months at least. If I compare that to conventional systems, you've got generally 1 or 2 design groups, then you've got a civil contractor, and then you've got a landscape contractor, and then some sort of establishment or asset manager. You only need one person to make a mistake or do something wrong to cause dramas with the system. And if you're a developer, if you've got and I've been in this situation before with a conventional bio, you're standing on the edge of it and the system doesn't drain, who do you blame? And what do you do? And often when it comes to that, it's just too late. I mentioned the QA/QC procedure for the manufacture of the filter media. That is super strict. Like I said, 25 steps QA/QC. If we get the filter media wrong and it's not in accordance with the specification, we basically have to chuck it out or start all over again. So it's very, very. It's strict for a reason because we know the filter media specification and achieving it is massively important to the success of these systems, and the same should be applied for conventional systems. Also, it's worth noting that there's over 20 years of R&D that's gone into developing these systems and installing them and managing and seeing how they operate. And that's a lot of that information is publicly available. So there's a lot of very smart people, well before me. Not that I'm smart, just there's a lot of people involved in making sure that this is done super right. So yeah, that's a key reason. And also resilience. So there's a lot of features within Filterra bioretention systems that enhance the resilience of these systems. I mentioned the mulch. I mentioned the filter media specification. I mentioned the fact that we do this turnkey approach. All these factors enhance the resilience, but also there's other stuff in terms of, for the bigger bioscape systems, we make sure that they're offline. They're not taking, all high flows. For the bigger bioscape systems, we almost always insist that there's a decent GPT upstream to help with pre-treatment, et cetera. So yeah, there's a lot of reasons why we think, that contribute to the success of the performance of these systems. So where to next? And a lot of this stuff, I should point out, I didn't even know about until I asked my R&D team. But yeah, long story short, at the Kingswood site, we're going to continue monitoring. We've done it for 5 years already. I often get accused of being really good at spending other people's money, or at least my director's money. And like, if I have my way, we'll continue monitoring for at least another 5 years. The results are really interesting. And so, yeah, why not, apart from the obvious cost? But we're also doing monitoring of, looking to initiate monitoring of larger scale systems. So often there's a criticism, this is a small system. What about your bigger systems? Ignoring the fact that music uses microcosm analyses from a lab to draw the bow that 2,000 square meter bioretention systems work the same way, which is another story. But long story short, we're doing additional monitoring of some large scale systems as well. We're also looking to improve a few, get some more data and design features around improving the performance of these systems, including a wicking system to help water from the, from below, from a submerged zone, for example, up to the plant roots and rhizomes. And we're also looking at some features to it, basically enhance seepage or exfiltration from the system into this the surrounding soil environment. We're also looking at investigating a few different mulch types, also looking at potentially looking at a different filter media blend to achieve a higher flow rate and still maintain performance. And not just for stormwater as well. So yeah, watch that space. We know we're really good at making bioretention media, and I think it's fair to say that it could be that know-how could be used for other innovations. So watch that space. I'm going to keep you in suspense and not give you any more information about that. But yeah, some really exciting innovations coming out of Ocean Protect over the next 6 months. You've probably heard about the new Ocean Guard using 90% plastic waste, the storm filter PFAS, which has got a lot of attention. But there's a lot of stuff we're looking to bring out in the next 6 months, courtesy of our very smart research and development team. And look, that's it for me. I can't believe I can see 14 questions in the Q&A already. I'm going to do my best to get through them. If you have additional questions that you'd like to ask, please put them in the Q&A. If I don't get a chance to do it, and I'm going to stick around basically until I answer all the questions. So if I haven't answered your question, please just hang around. But alternatively, you're welcome just to contact me offline. So without further ado, I'm just going to dive straight into the questions. I'm just going to bring it up now. Wow. Okay. I've never had so many questions in a webinar. I've been doing a lot of these webinars, so I'm going to try my best to get through them. A question from, I'm going to mispronounce your name, apologies, Sasi Manadeepan. May I know why the drainage rate is presented or / displayed as millimeters an hour instead of liters per hour or meters cubed per hour? It's probably just, yeah, it's a good question. I've never really thought about it, actually. It's probably just because sandy loam media or conventional bioretention systems are often presented as millimeters an hour. That's probably the historical reason, I'm guessing. A link to the presentation, same from Cecile. Yeah, look, I'll have the slides and the video recording up on the oceanprotect.com.au/webinars website, probably within 24 hours. So just to hang back then. But if you're desperate to get these slides, just email me, please. I can certainly do that. Here we go. So a question from Shamindri Blair. Their questions are, do councils in Southeast Queensland accept Filterra in basins that end up becoming council assets? Yep, most of these basins are often combined bio and detention basins. Does this affect the use of Filterra? Great question. So it does vary. Look, council approvals do vary across Southeast Queensland and Australia. In Southeast Queensland, off the top of my head, I can think of the following councils accept their use on private sites, so privately owned sites. So Brisbane City Council, Moreton Bay Regional Council, I think Sunshine Coast Council does now as well, Logan City Council, and I know Redland City Council accept them both on public and private sites, as do Bundaberg, which I know is a bit further north. Bundy Council accepts them on private and public sites, as does Townsville Council as well. But if you're ever in doubt, just drop me a line, because it seems like more councils are allowing their use each day. Yeah, can you provide indicated pricing for Filterra so we can compare with traditional filter meter? It does vary. Generally for the bigger bioscape systems, if I was to give a ballpark figure, and I don't like doing it, but I often get asked this question, so I'm just going to say it's generally about $1,500 a square meter for the bigger systems, and that includes everything that basically would be within the hole. So the under drainage, the gravel, the filter media, the mulch, the plants. We plant it, we put it all in, and then we look after it for 12 months. That's your price. So yeah, $1,500 a square meter. Conventional bio, I don't know, $500 a square meter roughly. So conventional bio is cheaper per unit area, but our systems are generally 3 to 5 times smaller. So in the cost comparisons that I've seen and we often get asked this question for specific projects, we generally find the Filterra bio is a cheaper solution. In addition to all the obviously other benefits, including the first 12 months worth of maintenance, et cetera. So thanks for those questions, Jamindri. Lucas Peralta, what is the reason for the negative 3% in NOx reduction? I'm assuming a negative reduction in addition to the outflow load. Is it attributed to oxidation reactions of the system? Yeah, obviously there's a transversion between NOx and nitrogen and whatever, but and I think that, like, long story short, I don't think it's achieving high rates of NOx reduction, but certainly when you look at the loads, there is a decrease in overall dissolved inorganic nitrogen removals. So I hope that answers your question, Lucas. Excuse me. Grant Atherton, is Filterra similar to the media used in wastewater treatment plant trickling filters? No, it's not. Trickling, and look, it's been a while since I was a sewage engineer, I used to operate a wastewater treatment plant many years ago, but no, trickling filters generally use like gravel or larger rocks almost. So yeah, ours is, I'm happy to sort of show you what it looks like, but basically it's basically looks like soil, granular soil with, you can see the organics within it, but it's certainly very different to a wastewater treatment plant trickling filter. Yeah. Could you please, a question from Sasi Manadeepan again. Could you please explain as how come your figures for load removal and efficiency increase with time age? It's a great question, and I actually don't think I've seen sort of to anyone sort of talk about this in the sort of stormwater space. But long story short, with age, so certainly after that first 12 months, you're going to get more biological activity. I would have thought so. The roots will spread further within the filter media. You're going to have more biological sort of, little biomes, et cetera, forming on the root rhizomes, et cetera. I actually think over time, you're going to get that increased biological activity just with age. So with the increased biological activity, there's more biological treatment processes happening. So that's where I think we're getting an improved performance over time, which, yeah, I haven't, and I've seen that in one other conventional bioretention study by Bill Lucas, but yeah, I think that's my explanation. I could be wrong, but long story short, yeah, I think these systems are just getting better with age because of that increased biological activity. As only if that was true for us all. What is a question from Rain Davidson? What is the K and pora? What is the K? I think you mean what is the K or hydraulic conductivity? The hydraulic conductivity, the design what we use in our modeling is 3550 millimeters an hour, which is, like I mentioned before, is a design rate, which is certainly conservative, so 3550 millimeters per hour. But we see in the field the hydraulic conductivity is certainly above, I think seems to be about 5.5 meters an hour fairly consistently. Courtney Henderson, greetings, Courtney. Can you please comment on frequency of bypassing and reduction in flow rates and volumes? Yeah, great question, Courtney. It's actually something I'll be presenting on a little bit later. There's been a study done by Contech on flow losses across Filterra systems. Long story short, we're seeing significant losses, likely due to exfiltration, so, as per we see in conventional bioretention system. The frequency of bypassing really does vary, as you might imagine. So it depends on your climate region. So obviously a system in Adelaide sized at using 0.3% of the upstream catchment is going to be very different to a system in Noosa. So it varies basically depending on the climatic region, but these are all things that we take into consideration or is assessed in our modeling and design that we do. I hope that answers that question. But yeah, in terms of the flow volume, it's something that where I'll be presenting on soon. But yeah, the study that I've heard about anecdotally, hasn't been released yet, shows significant flow volume reductions, which is really cool. Paul Dabowski from Urban Utilities. Yeah, how do DIN reduction values compare to conventional bios? He says no need to answer now. You can chat offline. Yeah, it's a good question. I'd really have to delve into the data, and I have got all the individual DIN reductions for the other conventional bio studies I refer to. But yeah, DIN reduction values for Filterra are significantly higher than conventional bios. Would be a general rule, I'd suggest. So I hope that answers your question, and I can present that data offline as well. So you might recall I did a webinar a while ago, does bioretention actually work? And I went through all the conventional bio studies looking at various things, including individual studies and their percentage reductions. But certainly for the conventional biosystems, we're often seeing, regardless of DIN reductions, we're seeing total nitrogen increases across the system. So again, DIN increases across the system for a lot of conventional bio studies as well, which we don't see at all for Filterra studies. Stevie Barisic asks, what is the filter media comprised of? Is it natural material? Is it recyclable, reusable at end of life? So just on that last point, end of life, there should be no end of life of these systems. The data that we've got to date, based on a few different studies, shows that these systems should last in perpetuity. So the filter media should never be needing to be replaced or have an end of life as such. what is it comprised of, though? I can't actually specify what it actually is comprised of. That is a bit of a trade secret, but it is natural material. It is all sourced from local sources within, so it's basically all made in Western Sydney, and in our facility in near Preston's in Western Sydney. So it's all made from locally available sources, and that's probably all I can probably specify. But yeah, if you held it, you'd probably look at it and go, yeah, there's organics, there's granular material, etc. So yeah, it looks pretty natural to me, that's for sure. How well does your question from Rain Davidson? How well does your model? Sorry, I'm going to get this right. How well does your media model correctly through the music program? It's a great question. This is something I've done a few times. I've actually compared how what music predicts relative to the field study that we've done, and I'm almost amazed to say that the results are actually really similar, like almost bizarrely similar. So I've looked at music predictions versus the real world data from our Western Sydney study. And there's a whole bunch of fancy stuff I have to do with changing the flow and pollutant time series, et cetera. But long story short, music using the bioretention node, provided you change some of the filter media characteristics, like hydraulic conductivity, TN, ortho P concentration, et cetera, as per what we recommend. Music does a really good job using the bioretention node of predicting the performance of Western Sydney, which is great. Now, I haven't heard anyone do that for conventional biosystems. But look, I know that the music bioretention node, if you use the as it is, it's the algorithms within music use basically data up until 2009 from Microcosm studies from Monash University using synthetically dosed stormwater, and but there's been no field verification of those systems for conventional biosystems, but we've done it certainly for Filterra. Tracy Vermeulen asks, is there a Filterra installed in Western Australia? Not as yet. I think the furthest west we've gone so far in Australia is Adelaide. But look, if you're keen to explore that potential, Tracy, we're certainly doing work in WA. So if there's an opportunity, just or interest even, just let me know. Cool. Rain Davidson asks, I would be interested in seeing your particle size distribution graphs. I'll have to take that on notice, Rain. We might be able to provide that, but I'd have to check with the powers that be. You could probably just take a sample and do it yourself if you're being extra sneaky, but not that I'm encouraging you to do that. Cool, man. My voice is shredded. That's a lot of questions. If you have, there's been a few come through just sort of saying that they want to email me separately. And obviously you've got my email addresses on the screen. But I'll give people one more chance to ask any final questions, but if there's none further coming through, just a very big thank you to, there's a couple of have just come through. If a question from Shaw, Avery, no one's asked this question, Shaw, if you want to use trees, which one would you recommend to use with your system? How much distance between them? Look, in terms of tree specifications, it's fairly consistent with the recommended tree species that you probably see in bioretention guidelines, whether by Water by Design or others. Long story short, you generally want trees that are tolerant to dry conditions in addition to occasional inundated conditions, ideally with a good root biomass. How much distance between them? Again, it obviously varies between the tree species. Obviously, you want to give the trees a decent space to extend their branches, etc. Generally, the planting densities for Filterra systems are lower than conventional bios because we do want to get in there and replace the mulch. But yeah, look, there's a really big planting palette that we do have on our website on that review paper. But if you want to use something specific to your site or your local environment, yeah, that's something we'd certainly encourage. And particularly, obviously, we want to encourage local species as best we can to encourage, local or enhance local biodiversity, etc. But look, we might cut it there. If you do have any further questions that you'd like to ask me, please feel free to reach out. My email address and phone number are there. Just a very big thank you to everyone who's dialed in today. Really appreciate it. And if you'd like to know more, feel free to reach out. But without further ado, Enjoy the rest of your day. A reminder that the webinar recording and slides will be made available on our website. So if you're keen to get a copy, just jump on there or just email me directly. Thanks, guys. Enjoy the rest of your day, and I look forward to hopefully seeing you guys in person sometime very soon.